All right, we're in section 2.1 where we're going to use inductive reasoning. So first thing, we have some definitions that we're going to take a look at, and they're going to help us better understand what we need to do when it comes to inductive reasoning. First off, when you're performing some kind of inductive reasoning, you have to make a conjecture. A conjecture is an unproven statement that is solely based on observation. So it's nothing doing with like a formal proof. It's just conjecture of something that you observe. The inductive reasoning is the process of finding a pattern for specific cases and then writing a conjecture for the general case. So, you have a problem in front of you. You gather up all the information you can, and then you make your conjecture. Counterexample is when you, in specific cases in which the conjecture is false. So sometimes it's true in some cases, but if you can determine that that your conjecture is false using one other example, then that's the counterexample. So looking here, we have uh, an example where we have figures 1, 2, and 3. And it looks like the first example we have a horizontal line going through a rectangle, and it looks like it's shaded blue on the bottom. Figure 2 looks like we have a horizontal line in the middle, and now we have a vertical line down the middle, and then the shading of blue is in the bottom left. Figure 3 is we have one horizontal line in the middle, and now two vertical lines, which make it into three different parts, which is 6 total. So it looks like it says each rectangle is divided into blank as many equal regions as the figure number. So it looks like it's uh, divided into what is two or twice as many equal regions as the number. So it looks like you have figure 1, you got 2. You have figure 2, you have 4. You have 3, you have 6. All right, so it says the fourth figure by dividing the rectangle into, it will be 8 because you have figure 4. 4 times 2 is 8. So that's the conjecture from observations. And then from here, some more observations we look at. The shaded region appears to be, looks like on the bottom, and from figures 1, 2, and 3, it figures the shading is to the left. So what we're asked to do now is to figure out what figures 4 and 5 are going to look like from figures 1, 2, and 3. So if you're going to make them into 8 parts, looks like there's one that goes right down the middle, and then we got 1, 2, 3. So now I got 8, and then the blue, make it blue. The blue goes here. And then figure 5 will go here, and now we'll have 4. So then I got 1, 2, 3, 4, which makes 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then again, the shading is to the left. All right, you don't have to put the dots on. You can try to erase them if you need be. Go from there. All right, so that is kind of how we made our conjecture and made our inductive reasoning from um, the illustrations that were given to us. Here, we're asked to describe the pattern of -1, -4, -16, and -64. So, and they're also asking us to write the next three numbers in the pattern. So, anytime you have numbers and patterns, uh, a lot of times you kind of look at each individual section. So you got -1, you got -4, and then you got -16, -64. It rises quite a bit So anytime that it rises drastically and it doesn't seem like there's like an addition pattern or a subtraction pattern, I'm led to believe it's either multiplication or it's exponents. So I always look at the very first one. Uh, with -1, what do I got to do to make -4? Well, if I took -1 and multiplied it by 4, I would get -4. All right, now I got to see if it works for the other situations. So if I took -4 and times it by +4, would I get -16? Yes, I would. You know, would I, if I took -16 and multiplied it by 4, would I get +64? The answer is yes, I would. So what we're going to do is we are going to multiply each number 4 times the previous number. So to figure out the next 3 numbers in the sequence, it would be like -64 times it by 4, which would give me -256. Then if you took -256, multiplied it by 4, you would get -1024. And multiply it by 4, you would get -4096. So now here they're asking us to describe the pattern of numbers 1, 2.5, 4, 5.5, and then they want us to write the next 3 numbers. So since these numbers didn't rise super drastically, I'm led to believe that it is like an addition problem because the numbers increase in the pattern. So if I look at the very first one, and what I would just do is I would just take 2.5 and subtract it by 1, and I get 1.5. So I want to see if I have to add 1.5 to each one of the numbers in order to get the pattern correct. So if I went 2.5 and added it by 1.5, well, do I get 4? And the answer is yes, I do. And then hopefully, if I take 1.5 again by 4, I should get 5.5, which I do. So that means that my conjecture here is I'm just going to add 1.5 to previous number. And since I'm going to add 1.5 to each previous number, the next 3 numbers in this sequence would be 5.5 plus 1.5, which would be 7. 7 plus 1.5 would be 8.5, and 8.5 plus 1.5 would be 10. All right, so below here, we have this diagram here. It says give 5 non-collinear points, and it says make a conjecture about the number of ways to connect different pairs of points. So it says it says make a table to look for a pattern. So like we have this pattern here. So the first portion of this diagram, which is right here, we have 1 point, we have 2 points, 3 points, 4 points, 5 points. So if we notice in the pattern, in the number of connections increase, because we have more points, you can use the pattern to make a conjecture. So right here, with 1 point, we make 0 connections just because there's no other line, no other point to make a connection with to make a line segment. When you have 2 points here, got like say like point A and point B, we have 1 connection. If we look at uh, 3 points, you got, let's say, A, B, and C. Looks like AB, looks like AC, and it looks like BC. So we have 3. All right, let's get more challenge. So I got A, B, C, and D. Looks like I have 1, 2, 3, 4, 5, and then 6. And then it gets a little bit uh, more challenges because of more line segments, but we can actually now we start to form a pattern. So if you look here, what did I have to what what added from 0 to get 1? So if I took 0 plus 1, that gives me 1. Now, what do I have to add? If I took 1 plus 1, do I get 3? No, but if I took 1 plus 2, that gives me 3. And then here, if I go 3 plus 3, that gives me 6. So all I'm doing is with each one of these second numbers, I'm increasing it by 1. So I'm taking the number previous and then adding another value to it to the sum. So in this case here, this should be 6 plus 4, and I should get 10. So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 connections for 5 points. All right. So again, you connect 10 different ways. And so suppose we had a sixth one. So the sixth one would just be 10 plus we'd increase this one by 1. So we have 5. So if we had 6 points, we would have 15 connections. All right, so here it says numbers such as 1, 3, and 5 are called consecutive odd numbers. They want us to make a conjecture about the sum of any 3 consecutive odd numbers. So if you look here, we have a series of consecutive odd numbers. 1 plus 3 plus 5, 5 plus 7 plus 9, 3 plus 5 plus 7, and 11 plus 9 plus 11. So if you look, they give you the sum of 1 plus 3 plus 5, which is 9, but they're also telling you that 3 times 3 equals 9. 5 plus 7 plus 9 is 21, and 3 times 7 is also 21. Look here, 3 plus 5 plus 7 is 15, and 3 times 5 is 15. And then finally, I have a 7 plus 9 plus 11 is 27, and 3 times 9 is also 27. So the conjecture that we have here is the sum of any 3 consecutive numbers is also going to be, and if I look here, it looks like it's going to be 3 times, because each one of these has 3 to start with, 3 times it by, and if you look, the second number is always the middle number. So 3 times the middle number. Okay, so they want us to test this to see if it's true. So if I go -1 plus 1 plus 3, that gets me 3. Does 3 times 1 give me 3? Yes, it does. It checks out. Let's try this one. 103 plus 105 plus 107. That gives me 315. Does 3 times it by 105 give me 315? Yes, it does. This checks out. So we can say for this one, our conjecture is true from our test results. Here it says make and test a conjecture about the sign of the product of any 4 negative numbers. All right, so my conjecture will be this. About 4 negative numbers, it says if you take 4 negative numbers and multiply them, the result will be positive, will be a positive number. So if we'd say like, all right, like -1, negative number, -2, a negative number, -3, and -4. If I multiplied all four of these together, I would get a positive 24, and it would work for any four negative numbers as a product. Okay. Here, it says a student makes the following conjecture. It says the difference of any two numbers is always smaller than the large number. All right, there's some conjectures that can be disproved. Anytime you disprove a conjecture, you need a counterexample. All right, to find a counterexample, you need to find a difference then is greater than the larger number. So you could say something like 8 minus a -4 is going to equal 12. All right. Eight's the larger number. It's a difference, and the result became larger than that larger number. So because 12 is greater than 8, a counterexample exists, so the conjecture in this case is false. So here, they want us to find a counterexample to show that the following conjecture is false. That says the quotient of two numbers is always smaller than the dividend. So in here, if we looked at long division, the dividend is always inside that fraction or that division sign. The divisor on the outside, the quotient's the result. So we could say that a dividend of 2 and a divisor of 1/2 or 0.5 is going to result in a number larger than the dividend, which is 4. Okay, so since 2 divided by 1/2 equals 4, that makes that conjecture false. Here in this last example, it says we have a scatter plot shows the average salary of players in the NFL since 1999. It says make a conjecture based on the graph. So if you look here, these are years since 99. So this is like 99, this is 2000, 2001, 2002, 2003, 2004, and then each dot represents the average salary in thousands of dollars. So looks like the average salary in 1999 was $700,000. 2000 was 800,000, and it seems like it goes upward from that from the graph. So looking at this scatter plot, it shows that salaries increase each year. And since that increase seems to be happening, one possible conjecture would be that NFL players are earning more money today than in 1999. So here it says make make a conjecture that could be true about NFL average NFL salaries, and then give an explanation that supports your reasoning. All right, so what we can say is just by looking at the graph seems to be moving in an up, in a positive slope. So it's not necessarily linear, but it would definitely would be increasing over the course of um, many years. And that is being able to use inductive reasoning. Hope this helps. Until next time.